Circles and central angles. Let's reacquaint ourselves with some of the parts of a circle again. What do we call this here? When it's in the circle, the center, okay? So we have the center of the circle right here. It's going to be very important for today with circles and central angles. Eli, what's the question? Do we have homework? I think that's old. I think it's old. All right, that's okay. Circles and central angles. Now, what do you know about a central angle? Well, a central angle for a circle is going to be an angle that is formed using the center of the circle. Okay? Because on a circle, you may also have one of these in red, which is known as a chord. Did we talk about a chord before? A chord is a part of a circle that has both of its endpoints on the circle, but doesn't necessarily have to go through the center of the circle. Now here, there are all angles, but are they central angles? Are they formed using the center of the circle? These here? No. So these are what we have as far as central angles are concerned. What would we call this line right here? What is that? The radius. Very good. This is also a radius. Okay? How many total degrees? We talked about triangles, and we talked about that a triangle had 180 total degrees. We said that these quadrilaterals had what? 90, 90, 90, 90 was 360. What about a circle? And we're also looking at 360 total degrees, okay? If you go up, if you spin around once, you make one rotation, that's 360 degrees. Now, there's a lot of other things that we can think about, that we can find out using central angles. If I have a central angle that looks like this, it's called what kind of an angle? It's a right angle. If I get another one that's also 90, I can split my circle basically up into 4 right angles. Now these, either way you go, would combine, this 90 and 90 combine to make this straight line, which makes them what? What do we call that? When the sum of two angle measurements equal 180. Supplementary. Very good. Supplementary. Or even these two up here give me this straight line, or these two there give me that straight line. So you have a series of supplementary angles here. Okay? Let's take a look at 375. Let's look at the guided practice and see if we can't figure out what some of these angle measurements are. Just trying to use some common sense, I suppose. Let's see. Drawn like that. E, F, D, C. They give us some other stuff here. Give me an AB. degrees and z. Now, believe it or not, with the information that we have, we should be able to find out the missing angle measurements. Okay, so I say it's always easiest to just try to find this stuff out, then we'll answer the question specifically later. Angle y and 40 degrees, this angle here, come right across from each other. What do we call those? Remember that we had those special names? There's certain kinds of angles. Remember, they come right across from each other, opposite each other. They're called vertical angles. Vertical angles, okay, right across from each other are also what? Not parallel. Congruent, which means they are the same measurement. So if that's 40, angle y is also 40. Angle y and angle x combine to give you this nice straight line, which is how many degrees is a straight line? 180. If I already have 40 of those 180, what is angle x? 140. And angle x is a vertical angle to angle z. So if that's 140, that also has to be 140. Now let's see what other kind of information they need from us. Question number 1. The measurement of angle x was what? 140. The measurement of angle y? 40. The measurement of angle z? And 4 says the measurement of angle x plus the measurement of angle y. 180. Very good. Number 5, identify two chords that are not diameters. Give me a chord that isn't a diameter. Yeah. AB, and that's a segment, so remember I put a segment bar on the top of it. And DC, CD, same thing. Okay. Now, EC, would that be considered a chord? Now remember, a chord has both of its endpoints on the outside of a circle. Does EC have both of its endpoints on the outside of a circle? Yes. Now, we can call a diameter a chord because it fits the description. However, we can't call all chords diameters based on the definition. Okay? So a chord will cover a diameter because both of its endpoints are on the outside of a circle. Same thing with FD. Okay? However, some chords might not be diameters. Does that make sense? Yes? Now, question 6 has an interesting question to ask. Write the measurement of angle y as a fraction of the circle. What was angle y? 40. So 40 degrees of the total degrees in a circle. Can we simplify? Do they have 10 in common? 4 over 36. 1/9. Okay. Any questions there? Do numbers, page 376. Do numbers 7 through 13 right now. 7 through 13. 376, 7 through 13. Now, I don't know what you did, but like I recommended, I think it's easier for us to try to find out what some of these things are ahead of time. Anyone go with a particular strategy as far as when they saw this, you know, what did they think first or what popped out at them? Liam? All right, you just got to be careful, right? So what did you, are you saying this one here?
Well, yeah, kind of.
Yeah, so let's hold off on that vertical. If this did not have this 30-degree wedge taken out of it, then this would easily be 75. My gut feeling is this is going to be not 75. So let's go from a different angle here for a minute and see what we get. Frank? S and R? How did you find S? So you recognize that angle S and the 75 are supplementary. So angle S must be what? 105. And if I look vertically, is there anything interfering with R? Plus, not to mention that I also have 75 and R are also supplementary. So now here's what we should do. 105 and 75 gives us the 180. Let's add another 105. We get 285. Let's throw in that 30. 315. This 30 here, right? So if I have how many total degrees in the circle? 360. And I already have 315. Angle T has to be what? 45. Question. I missed one? K is supposed to go on the L2. Thanks, Eli. Thank you. Good. All right, now let's start. Now we've got all our information in there. Let's start answering some questions. Number 7, what's the measurement of angle S? 105. Number 8, what's the measurement of angle R? 105. 9, what's the measurement of angle L? T. 45. 10, the measurement of angle S and the measurement of angle T. 150? Because that L, remember, or is that T? Sorry, measurement of angle S and angle T. Sorry, it looks like an L to me. Because there's a period right after it in my book. Is there a period after it in your book? So it look like an L. 11, identify two chords that are not diameters. Give me a chord. Eli? KL. And did you put the segment bar over the top of KL? And JK? Yeah, no joke. And 12. The measurement of angle T as a fraction of the circle. So once we've established that angle T is what? 45. 45 over 360. Anyone come up with that? What do we got? Okay, did we simplify it? It is 1/8. How do we figure it was 1/8? You just start chopping it down? Start chopping it down. And then, what is 75 degrees? Where do you go from here? What do you do if you're not sure how to chop this down? What method do you use? Do you ever get like a really big cheeseburger from like a Fuddruckers or something? Yeah. Like, do you take it down in like one bite, or what do you do? Take it down how? Bit by bit, right? This ends in a 5, this ends in a 0, which means I know I could divide them both by what? 5. 75 divided by 5, is that 15? And 360 divided by 5. It's what? 7. 72. Okay. Am I done? It looks like it's done, but is it done? Because they're both divisible by what? How do you know that 72 is divisible by 3? What's the trick? Add the digits. What's 7 plus 2? 9. Is 9 divisible by 3? And so is 72. So we got 5. What is 72 divided by 3? 5 over 24. How many hours are in 3 days? 72. Everybody here today? No one's sick? Is she on vacation? Florida. All right. Worksheet 14-8 and 3 through 8. Real simple.